All right, welcome back. We're now going to go over the 30.3 practice homework. This is much more just straight math, and we just have to do something with parametric. The first one is, like what we got started off in 30.2, is combining our two normal parametric, so x of t and y of t, which we have for the first three problems. So what we need to do here is, according to 30.2, solve for t and plug it back into y. Except for if we look at these three, each one has a square, and that's not going to be that simple. But sometimes we can look for that chunk or block or whatever you want to call it of the same type of looking information. So if we compare the x and the y in number 11, there's not much in similarity there. So we don't get a break, so we do actually have to solve for t. So let's try that out first. We have x is equal to the quantity of 3t minus 2 squared plus 2. So we need to start solving for t. So I subtract 2 on both sides. All right, and then to undo the square root, we have to take the square root of, to undo the square, we have to take the square root of both sides. So we get the square root of x minus 2 equals 3t minus 2. So we can add 2 on both sides to get the square root of x minus 2. Notice how I end the square root plus 2 equals 3t. Divide by 3. So we get x minus 2 plus 2 all over 3 equals t. So now we have t and y, so we have to substitute it in. So we get y is equal to 3t plus 3, so 3 times the quantity of the square root of x minus 2 plus 2 all over 3 plus 3 all the way on this outside, right? Because we're taking this t and we're substituting all of that in for it. So lucky enough, these three cancel out, so we get y is equal to the square root of x minus 2 plus 2, and then that 3 comes down, and then we can just clean it up a little bit, not too much, so x minus 2 plus 5. So that is what we will get. That's our rectangular function for number 11. Moving on to number 12. If I look at this, we finally catch a break because we have this t plus the t squared plus t squared. So we don't actually have to solve for t. We're just going to solve for t squared. So if we start that off, we have x is equal to negative t squared plus 16. So again, we're just trying to keep the t squared. That's what we're trying to get by itself. So we subtract 16 on both sides. X minus 16 equals negative 2t squared. Again, just solving for t squared. So then we divide by negative 2. So then we're not even going to try to clean this up. We're just going to hope that stuff cleans up when we plug it in. So we have t squared by itself. So that means we can plug it in for what we see. So we have y is equal to t squared plus 12. We're taking what we have for t squared and plugging it in. So we get y is equal to the quantity of x minus 16 over negative 2 plus 12. The negative 2 doesn't cancel out, so we should distribute it. So y is equal to negative 1/2 x, right? The reason why I say that is because we could say y equals to x over negative 1, 2. I'm sorry, x is x divided by negative 2. But that doesn't look as nice as y is equal to negative 1/2 times x. Negative 16 divided by negative 2 is positive 8 plus 12. So we get y is equal to negative 1/2 x plus 20. So that is our rectangular function for number 12. Number 13, we're even so much more lucky here because our chunks are so much more elaborate. Sorry about that. So all we need to do to clean up our x one before we can use it to plug it in is to move this 9. So we can subtract 9 on both sides. So we get x minus 9 equals t plus 2, all of that squared. Because we got all of this by itself, we can plug in our x minus 9 into where that t plus 2 quantity squared is. So we have y is equal to negative 4 times x minus 9 plus 40. So now all we need to do is distribute. Y equals negative 4x plus 36 plus 40, and then combine like terms to get y is equal to negative 4x plus 76. So it turns out the one that might look the most scary because it has all this extra stuff in it was actually easier than the one above it, and definitely easier than number 11. All right, so that's all having x of t, y of t, and using both of those to get y of x. Now for number 14, we have y of x and y of t, and we want to use this to get x of t, our missing parametric function. So this one was the one that during notes I made it look very confusing, but we found the easier way, which is because we have y on both sides, and we could just ignore this. We have y by itself already, so all we need to do is set these equal to each other. And then since we want x of t, we need to solve for x. So first let's distribute that fraction. So we get 2/3 x minus 2/3 times negative 6. 2/3 times 6 is 12/3, which we can just rewrite as minus 4 equals 2t plus 8. We can add 4 on both sides, combine those right away, so we get 2/3 x is equal to 2t plus 12. So the best way to get rid of this fraction would be to multiply both sides of the equation by its reciprocal. So we flip the fraction, so we get 3 halves on top, which means these 3 cancel out and these 2 cancel out. So over here we need to do 3 halves as well. So that means we would get x is equal to 3 halves times the quantity of 2t plus 12. So if we distribute that, we would get x is equal to 6 over 2t plus 36 over 2. And we can definitely simplify those fractions to get 3t plus 18. So that should be our answer for number 14. And I don't think we got to this at all when we were checking our answers. And then lastly, 15. You have y of x, you have x of t, and we need to use both of these to get y is equal to t. This one's not bad at all, because all we need to do is plug in x of t into our rectangular function. And that's because if we notice, if we get rid of that function notation, we have x right here, so all we need to do is substitute. So we have y is equal to, and then we're going to take that whole thing that x is equal to and plug that in. If we look at this, we really don't need those parentheses because there's nothing else really going on. So let's just rewrite that without the parentheses. This is probably a step that you don't need to show on your work, but I like showing it as a teacher. So then we get the square root of 4t minus 1. We just need to see if we can clean this up somehow. 4t minus 1. We could factor that to 2t plus 1 and 2t minus 1, but that doesn't help us at all because those aren't the same factors. So that is the most simplified answer here for y in terms of t. So if we really want to rewrite that, we could do y of t equals the square root of 4t minus 1. So that is the end of our homework review. Hopefully that answers some questions. If not, please come to seminar. You're probably watching this during seminar. So good luck. If you want, I'll try to be in my classroom during lunch. Come at like 11:05 or 11:10 and come with some quick questions so we can work that out before I pass out the group quiz. Good luck.